Today we will be discussing on an important topic: why university research do not get converted into product or services. It's a very dear subject for us, rather tech forum, and most of the industry friends. This has been discussed, but no amicable solution so far in place. So it's a small effort by tech forum to have listen to the academia as well as industry and then do brainstorming and come out with an amicable solution. What as a solution and try to create an SOP that how this can be done. Obstacles are there everywhere, I know, but obstacles one has to overcome, and ultimately whatever industry wants has to fulfill, because ultimately the taxpayers are taking care of the universities where the huge research is happening, and it has to get converted into a product or services. Ultimately, it should improve the GDP of the nation, which is most important, and that is not correctly understood by either. So we are starting this presentation today, and on 6th of August we will listen to industry. Then we will have a brainstorm together and come out with some action plan. That's the whole thing. The idea of organizing such presentation is not to blame or play blame game, but to work seriously on the issues addressed by both industry as well as academia and try to find the solution. So today's speaker is very well experienced, Dr. Shashikala Gangal. She is ex-professor Emeritus from UGC, ex-ISRO chair professor, ex-professor and head of the Department of Electronic Sciences, Savitribai Phule University, Pune. Such a rich experience, and I know her for my village days, and she was quite enthusiastically engaged in development of sensors. She has also done a lot of other projects and research, so she knows the exact difficulties of academia as well as industry. So today she is retired, so I told her to put everything very frankly, but not to focus blaming on anybody, but to bring the facts and reality, and then industry representative will give a counter presentation to understand the limitations as well as strengths, that is SWOT analysis of industry and academia. Without spending much time, I would like to give the microphone to Dr. Shashikala Gangal and requesting her to start the presentation. Over to you, Dr.
Yeah. Good morning, everybody. Am I audible?
Yes, please.
Yes, you are.
Yeah. And my presentation is seen by everybody. I mean, video is also presentation. Okay. Today I'll be presenting the problems faced by the teachers in the university for converting the research, university research, into a product services. I'll be explaining some of my own experiences through the projects which I handled during my active time. Of course, I'm not inactive now, but still, they may look to be the older projects, but the scenario, I believe that it has not changed much, and therefore, what I'll be presenting will be a status today also. Okay, go next to. The aims and objectives of the university can be broadly categorized into three main areas: academic excellence and knowledge acquisition, personal and professional development, and civic engagement and social responsibility. The universities are dedicated to pursuit, spread, and advancement of knowledge. They aim to cultivate critical thinking, problem-solving skills, encouraging the students to analyze information and develop innovative solutions. Universities are also centers for research and innovation, contributing to societal progress through new technologies and ideas. A fundamental aim is to allow students to specialize and gain advanced knowledge in their chosen fields. But converting the research into products and services. So the Indian universities, they do a lot of research on the topics of national and international interest. And both by faculty and the research students. The research output is published in reputed journals. The research is appreciated worldwide. Research papers are referred by a large number of researchers. But the thing is that they are used by other country people for advancing their research, but and converting that into a industrial product. But we are not doing that. I mean, there are certain problems which stop us doing that. The commercialization of the research will be beneficial for both academia and industry also. In academia, the enhanced research, it will enhance the research and development. It will get improved student employability. Faculty development will be there. Increased funding opportunities will be there. And the reputation of the universities will enhance. However, the university research often faces challenges in transitioning to practical applications like products and services. While universities focus on the fundamental research and knowledge creation, the emphasis in the commercial sector is on market viability and profitability and scalability. And it is difficult to match both these things because mainly the research, when it is basic research, it cannot go into a product. But the research what is done for the producing something or development of equipment that should be available to the industry, and there are certain problems. The first problems are with the challenges are due to the combination of factors like differences in priorities, lack of resources, inadequate support for commercialization, both from university management and from industry. Available time with the faculty, institutional policy, role of faculty members, students' perspective, and there may be few more factors also which will be helpful in analyzing the situation. When you consider a faculty, the faculty is expected to do teaching. It is their first priority, and 60 to 70% time goes, even if he is a professor, even if he is a lecturer or a reader, in whatever step he normally, between 50 to 70% time goes into teaching. And now the number of teachers in the universities have reduced, almost 50% reduced. And therefore, the teachers have to do more work for teaching. In administration also, they have to contribute. Typically, the time goes is 20%. And research is a third priority, wherein the faculty can put only 10 to 20% time. That is on selection of the topic, writes research proposals, defend and get funding, guide the research students, publish 5 research papers minimum per year in reputed journals, arrange and attend seminars, conferences. And in turn, the time available between 11 to 6 is not enough. And therefore, faculty has to work extra hours. He or she doesn't have a vacation. Or in vacation also, he or she has to come and work. Then there are resources from the university side are also meager. Basic research facilities are not available. Therefore, a teacher has to go in other institutes, begging them for giving their facilities for research work or associate with them and do certain bits and bits in the university. And then he or she will be eligible or ready for writing the project. Then one has to earn the funding from projects because university doesn't have any funding for research. No funds are available even for repairs and maintenance of the existing equipment. And therefore, when it goes bad, you have to keep it aside and get it from somewhere else, or use your research funding from the funding agencies to repair and maintain. It takes a lot of time, therefore. When it comes to uh, using the equipment from other departments or other institutes, other departments, especially from university, then no operators are available permanently appointed for operating those equipment. Therefore, it depends at the mercy of the teacher who is holding that equipment and the research student, which is who is working in that. He or she doesn't. It's not that they don't want to, but because of their workload or because of uh, their involvement in the research, it is not possible to get the measurements done, analytical measurements done very easily. It takes a lot of time, and therefore, when you prepare a sample and go for testing, the test equipment is not available, and then by the time you get the test equipment, your sample may have gone bad, and therefore the results you get something else, and that is the resources are lacking in the university. Then when it comes to a research student, employing the research students, getting the work done from them, the students are appointed through research projects. Some of the students come by earning their own scholarships through CSR, DOE, UGC, and therefore they would like to work on the projects they have submitted to the corresponding funding agency. And the teacher should have the interest in that, or teacher is, if given that student, if you want to quote that student, you have to go and enter into that particular topic. Then there is problems while appointing the students on research projects. It takes typically 3 to 4 months after receiving the funds from funding agencies, because advertisement, then reservation is now, there is a big problem because the university should have 50% reserved candidates from the research projects also. And therefore, if you're even if you have 2 to 3 project, research students which are sanctioned by the funding agencies, they may all be, and then you do not get the reservation reserve students of a proper category, and they have to you have to wait and advertise again. Even if you get that, the particular reservation student, he gets a better opportunity or gets employment in a teaching or in some industry, and then he goes away. And because he gets it in some government employment, and so he goes away earlier than the normal open category student goes. So then, and therefore, such students, they resign for better opportunity, or sometimes they cannot cope up with the work, and therefore 4 more months for a new appointment. And effectively, what happens is it's not possible to complete the project in time. And when it is not possible to complete a research project in time, then forget about giving that particular technology to the industry, because industry still further needs it in, they effectively need the work done yesterday rather than tomorrow. And that is effectively the time required. I mean, I'm not talking about the yesterday, but it is that they require a very fast development. Now these students, when employed, they are interested in getting their degrees as early as possible, and therefore there may not be, of course, it is not possible to for a basic research. and therefore he is interested in publishing it earlier, because for getting a PhD degree, the student should have minimum 3 uh, publications in reputed journals. And therefore, instead using his time for getting a better and better product type of thing, he's interested in the basic research and get publications and get his degree. That's all. Now, I will explain these problems through the projects which I have handled uh, with the industries, uh, with basic research and with funding agencies. Now, we had long back, it's not a very new project, but development of a 1 meter long glass scale, which is to be used for CNC machines and for automatic movement of the uh, X, Y, and Z stages, etc. This project was given by Electronica. Late Mr. Prakash Ratnaparthi was very helpful in that, and he was interested initially in getting such things done. Now, this scale, it is expected that it should have a line and space pattern, that means markings, with 10 micron pitch throughout the length of a glass scale, and that was a very challenging job. It requires the use of photolithography technique. We had mastered before that this technique for 10 micron pitch on a 3-inch length. But converting 3-inch length into a 1 meter long scale was really a challenging job. Now, the student has to have knowledge about on the photolithography. He should have the mechanical skill for handling the equipment and developing the equipment for that. And the research student in the university is having a different mindset, and therefore what we discussed with Prakash Ratnaparthi, that we appoint a student in the industry. So in the industry, that was to avoid the delay in appointing the student, and directly when that student is ready, he will be employed further and given a further permanent job in the industry. And that was our thinking, and therefore we employed a student to do this work. And we had written a MOU with the university and the industry to accept this particular arrangement. Now, availability of optically flat glass was a problem, because it needs to, if it is not optically flat, then the lithography cannot be done in a good way, and then there will be a change in the pitch required. So we utilized an imported scale as a master mask for this technique. For it requires a photoresist coating on complete 1 meter length and a uniform exposure of the mask pattern on the glass 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 plate uniformly. And therefore, we developed a photoresist has to have a very uniform thickness. It should not have a variation of the thickness over the length of the tube, length of the glass scale. And the exposure also has to be uniform to get the proper transfer of the mask. And we required a development of such equipment, and that was done. I mean, that was funded by Electronica, and we could get the equipment required. It was tested, it was utilized, and we could get few scales made in a good shape. Now, throughout this process, Electronica fully and wholeheartedly supported the project. But however, the time required was quite long, because everything was to be developed. I mean, we were comfortable with a smaller mask, but 1 meter length was a challenge. I mean, we took that challenge and we could do that. And it was found that the scales available in the market are cheaper. So naturally, the project, though it is completed, it could not see the market. And that is what I mean, spending all this amount and getting the experience, developing the equipment, we could not go into it doesn't go into the market. And that was not a failure, but I mean, academically we got everything, but the product did not see the market. Then we were interested in developing a Hall sensor for RPM measurement of vehicles. This project was given by Defense, PRD, Vehicle Research and Development Laboratory in Nagar, from Nagar. And they wanted such development and they funded us the project. This particular Hall sensor was developed. A Hall sensor typically has it's a square. It has a silicon wafer, which is having a Hall can develop a Hall voltage. Then there are 4 contacts. These contacts should be ohmic contacts, and the dimension of the wafer, I mean, this particular sensor was 4 millimeter by 4 millimeter. There were 1 millimeter by 1 millimeter pad. I mean, the sensors can be smaller also, but with the technology what we had that time, we could have. I mean, we finalize this dimension, and then this is to be connected to a PC because this 4 mm by 4 mm is not an handleable wafer, and so if you touch it and all that thing, the characteristics of the sensor may go bad, and therefore it has to have a handleable area, which is a PCB, which is having a pad of 1 millimeter by 1 millimeter, and the wire was connected to through. I mean, this wire connection also is an important thing. One has to bond it, but bonding machine was not available. Therefore, we connected it to silver paste. So we initially had a mass preparation, cleaning of silicon wafers, deposition of titanium, platinum, and aluminum, which is this contact, and this is done by evaporation, transferring the mask pattern by lift-off technology, and we have to anneal these contacts, I mean, titanium, platinum, aluminum, to get an ohmic contact. Ohmic contact is the one which doesn't have, I mean, the IV characteristic of it goes through 0. That is the requirement for ohmic contact. And then this 4 mm by 4 mm cannot be handled for deposition, etc. So we were having a 1 inch by 1 inch wafer on which we developed a number of patterns, and afterwards we scribed the wafer to separate the all devices of 4 mm by 4 mm, and then we encapsulated it. So the size, then we passed the current through 2 of the contacts, opposite contacts. A magnetic field was applied perpendicular to the wafer, and the Hall voltage was available on the other pair of the contacts. So we required a magnetic field of 4 kilogauss, but at the surface of the sensor, it needs to be 500 gauss. So because the magnet cannot be placed directly on the sensor, we use the 4 kilogauss magnet, a small magnet, and the distance between the sensor and the magnet was typically 5 millimeter. So we could get a Hall voltage of 0.2, 0.4 millivolts. Now this has to be amplified for signal conditioning for actual measurement. So this is the signal conditioning unit, and so finally we could get a 5 megahertz crystal oscillator was used as a standard one, and we could get a counter, counting the number of rotations of the wheel, which goes near the near the sensor. So on one side, there will be a magnet. On the other side, there will be a wheel. The magnetic field will be cut during the wheel movement, and we can measure the RPM. So the whole sensor characteristic was linear. The time stability was very good. It required 10 milliampere of current only. The temperature stability was also good till 65 to 70 degrees centigrade, and so we could successfully do it. But there were some problems which were faced. The wafer size we used was 1 inch by 1 inch. So out of 1 inch by 1 inch, since because of the laboratory, uh, all these silicon sensors, they require a class 100 at least environment. And we could do in a class 100 environment using typically a one clean air system, which is used only for the vacuum system which you have. It will be near. So other area of the laboratory was normal. So we could not, there may be some dust particles sitting on the wafer. There may be some oil vapors coming from the vacuum system. And therefore, out of 1 inch by 1 inch, we could have had somewhere around 30, 40 the sensors. But out of that, we could get only 10 good Hall devices. Now, connecting wires to these devices using silver paste. And mounting this sensor on having an enclosure for this. We use a metallic cylindrical pipe having 1/2 inch diameter and 4 inch length. And we had put the sensor on the mouth of the pipe and the electronic circuit on the back side and the wires from the other side of the pipe. But it was not looking very attractive, and it was not very industry-like or commercial product. We wanted to have that, but getting large number of such sensors, we required scaling up and getting the good yield of the processes. We need the processes to be done in semiconductor device fabrication facilities. And these device semiconductor fabrication facilities, class 100 facility, all those lithography also in a class 100 room, etc., etc. The facilities were available in Semiconductor Complex Limited, Chandigarh, and Bharat Electronics Limited, Bangalore. But these industries, they were doing their own devices, and they were not ready to give their facilities to fabricate the custom device like our Hall sensor. And therefore, in turn, what happened that even if with these developments, so the resources or the facilities are not available, and in turn, the development remains the record form. Then the third project which I presented in my last lecture was human pulse detection. This work, we started working on this right in the year 2006, wherein this concept was not there in the research field, or we did not get any reference before this on this topic. And we published our work in 2007, 2008, 2009. And the first student of on this Nadi Pariksha Yantra got his PhD in the year 2011. This is the equipment we developed, and you can see that these sensors which are put on the human hand were quite clumsy and very heavy and all that thing, and we wanted to change this into a robotic hand. These are the pulses which are available, and we could analyze these pulses. The researchers involved were myself, led Dr. R.N. Karekar, led Dr. Haribhav Kulkarni was Nadi Vaidya, Mrs. Asavari Padke Kulkarni, Nadi Vaidya. He still helps us in such problems. And Dr. A.E. Kalanke, Dr. Vesh Mahale. They got PhDs afterwards. and in 2011 he got it. Since we started this work right when nobody was in the field, we could have patented the idea in 2007, 2008 only. Of course, this equipment, I mean, this type of work was being done by BARC for the measurement of human pulse, but they were passing a current through the hand, electrical current through the hand for getting the pulses measured. I mean, passing the current through your human body may turn out to be, they also knew this problem, may turn out to be fatal depending upon the person or the human being. And so our thing was a non-contact, it's a ultrasonic sensor or a pressure sensor which was uh, not taking part in the human body, but it's on the surface of the body. So it is placed on the wrist. So we could have patented the idea in 2007, 2008. And however, we could not do that because for the two reasons, it required an approval and funding from university for applying the patent, and which we did not get because the patent, employing the patent lawyer, we cannot fund because that time my salary was also around 2,500 and all that. And so, not 2017, 20,000 around. But in that, applying for patents requires quite a lot, and therefore we could not do that. And that required approval from university, which we did not get. And then the students who was working on it, he needs a minimum 3 publications before submitting the thesis. And therefore, we published the work. And once it is published, it cannot be patented. Further, in order to have a pulse sensor developed for human pulse detection, they were using ultrasonic sensors, which were commercially available, and they were quite, I mean, when putting it on the hand, it used to prick the human body. I mean, it was not very comfortable on human hand. Therefore, we wanted to have a smooth polymeric materials, piezoelectric polymeric materials, which is flexible, high operation bandwidth, having low acoustic impedance, it's biocompatible and chemically inert, and ease of fabrication in the form of films and other shapes. And therefore, we took up this basic research and we developed the PVDF material. We developed a PVDF material for using it for the pulse sensor, or it's basically a pressure sensor. The material needs to be a beta phase material because it has a higher sensitivity when it is a beta phase. The material is available in alpha, beta, gamma, and delta. So we wanted to have a beta phase more in the particular material. So we started working on it. It can be developed, I mean, can be obtained using a physical deformation, staging or spin coating, electric cooling, quenching, and making the composites of the materials. But with the available facilities, with some of them which are purchased and some of them which are available, we use the spin coating technique, which is a simple one, and then we use the pooling technique for getting a better beta phase in the material. So we did all these things and we utilized it in our pulse sensing. These are the sensors which you look at, it doesn't have a very good commercial look. So we wanted the industry to help us, but by the time we could get acquainted with the industry and all that thing, the student left the PhD after getting his PhD on this particular basic development. This also we could not patent because the So we could have done that, but research student he left after getting his PhD. And then, I mean, while patenting, we have to then repeat it and give number of inputs to the patent lawyer. So we could not do that. So it remained in the again in the thesis form. It is possible to use these films for other pressure measurement also, and we are having this technology. And if somebody is interested in such pressure measurement application, we can offer this technology for the industry. But we have not, since the student left and I also got retired after that, it remained in a research form. Uh, uh, then we could not appoint also the new student because no funds were available. And engineering aspects of the package development are not known by our research science students because we lack in that particular thing. And I suggest that the science faculty also should have some component of engineering, uh, at least basic information on the mechanical and electronic and packaging things should be added in the syllabus. Then these are few projects which are added, but there are a number of other problems also which we face during while doing this research. The appointment of student, I talked about it, and it requires at least 4 to 6 months to start the project. And then the 6 months are gone west while doing this. And the faculty all has to do own work or get the things done from the MSc students and all that thing, which is not of the level which we wanted for the research. Purchasing of the equipment is another problem. So we get funding for a specific equipment. Of course, writing a project and getting the project, it takes around 1 year, 1.5 years, 2 years also sometimes. So by the time we in the project we write the equipment cost to be such and such. But by the time we get the funding, the cost has already. After we get the equipment, we require at least 3 months in purchases, uh, inland purchases, minimum 3 months, and for imported equipment purchase, it takes around 6 to 8 months or more than that. I'll tell you my experience in purchasing the equipment. We purchased a scanning electron microscope for converting the same into an electron beam lithography machine, which work I did in Japan, and I wanted to repeat it over here. So the funding agency, after number of presentations and number of problems faced, they gave me 20 lakhs for doing that conversion of ATM. The funding agency had provided 11 lakhs for purchasing the scanning electron microscope. So we wanted on the scanning electron microscope some facilities like motorized stage, XYZ motorized stage, and a beam blanking unit for writing the electron beam lithography patterns for developing it for the photolithography. So we the search for the equipment, the Cambridge was giving such equipment. We discussed with them. They were ready to add that beam blanking unit and motorized stage in their conventional scanning electron microscope. And they said that we had, I mean, the equipment is 13 lakhs. Now this, we were having only 11 lakhs, so we told them that we have only this much amount, and so please give us, it is useful for this, and it is development of students. And because we were having, I mean, ours is an educational institute, the Cambridge people, they accepted our request, and they uh, quoted us 11 lakhs of it. This took further, our funding agency, our finance officer says that you get still more discount and all that thing. I mean, in 11 lakhs, 2 lakhs of discount already which was provided, and the funding agent, the Cambridge was not ready to give that. And so after a number of discussions with the finance officers and all that thing, we could get this equipment into 10.5 lakhs or something like that. So, I mean, we purchased that, and in all these imported equipment, we require minimum 37 signatures while starting. I mean, getting the first signature from the head of the department for approving the purchase. I mean, Form A, Form B, etc., etc. 37 signatures were required. And by the time the validity of quotation expires, and then if it expires, then few more signatures will be required. And in case of this scanning electron microscope, what happened was, um, we could get the order was placed. We were to, I mean, it was, I mean, bank transfer from this to the other place. So we did all that thing. And when we were giving that check on that money, the dollar rate had changed. The dollar rate, right from 12 rupees, something it went to 20. So this 8 rupees per dollar was not possible in accommodating in all those things. So we purchased it, and then we had to go to the funding agency for giving us that other money, because the university fortunately had accepted to pay the extra amount which was required, and we had to get it. I have to give it in writing that I will get the funding done. I mean, the funding available from the funding agency, and if not, I will pay it from my pocket. That was the real thing written. Got it written by a finance officer in this particular dollar rate change, because which was not my mistake, but still I had to give it done. I mean, the researcher has to do this thing also. So we did not get the particular. I mean, we got it, we converted it, we utilized it for some of this. These students got PhD on it, but finally it happened that the requirement of this type of equipment was not there in the universities. We especially made it for the university, because to make them work in a semiconductor technology. But semiconductor technology was not, uh, I mean, geared up during that time, and therefore this remained as a research project. And it is afterwards that particular equipment got bad. The vacuum pump got, because nobody was using it for longer time. Then there is another problem that we had to, on any equipment we purchase, the finance officer or the finance department, university department, it tells us to get a discount as much as possible. And sometimes it becomes very difficult, and sometimes then we get a refurbished equipment rather than a new equipment, which may not be useful for longer time in the university, and we require the running of such equipment. Once we get it, we require it to be used for long time for training the students, and therefore it becomes very difficult. But our finance department doesn't happen. In one of the case, it happens that we were having Cadence software. This was a new software that time, and because our city university, I mean, educational institute, it was the Cadence people. They gave us 95% discount. 95% discount. I'm telling you again. And even after that, our finance officer said that you should get some more discount. I mean, so it is possible to get 95% they provided. I mean, they did not do uppar on us because it was a mouth-to-mouth publicity, and since the software was new, uh, if our students they use it, then 30, 40 students they use it, they go at different places afterwards, and they, I mean, publish it, I mean, publicity is done through mouth that I was using this thing, so somebody else also thinks of. So for that, they gave us 95% discount. But then this also, then our finance officer says that when it is 95% discount, why you don't ask for two pieces of the same, in the same amount? It was really very horrible to face such questions and hands off. Now, there is one more problem. Nowadays, while submitting the project to some funding agencies like DST, DOE, and all, the industry partner is required. And industries, unless they have a full faith in the researcher that this will turn out to be a product, and for getting that, we should have some research before that. And getting funds from somebody else, etc., which is sometimes not possible for the lack of facilities in the department, for the lack of available research students in the department. It is difficult to get the industry partner, and because we don't get industry partner, the funding agency doesn't give us the project. That is the sad part of it. Or otherwise, they reduce the funding, or they reduce the aims and objectives of the aims and objectives. They give a tit and bit to the funding agency, or they tell us to apply in some other section of their agency, funding agency, and then get the project. So finally, we cannot come out with a good product. Then availability of analytical equipment. I was telling this analytical equipment are available in different, or even if university has a common analytical equipment section or analytical equipment lab, which is there in the university. But each of the analytical equipment is with some faculty, maybe from chemistry department, maybe from electronics department, maybe from biology department, maybe from, and therefore there is no operator. No operators are appointed on this for using this or for this analytical equipment to get the data or maintain it or repair it or handle it. So research students are using it, or they are handling it, or they are operating it. And once that particular research student goes after his PhD, then other student has to be trained, and then so some time goes, and then the research student should have a time to take other samples and do his give the output to the other teachers. So it was not possible to get easy access to the analytical equipment also. So all these problems when faced, it becomes difficult to get a really industrial grade product out of the research which is done by them. I'm frank because I don't know whether the situation has changed now, but I hardly, I don't believe it has changed much. because the number of staff members also has reduced. In physics department, 40 staff members are there on the, they get the funding for the, government funding for 40 staff members, but only 20 are there on the roll. In our electronics department, there are 4 staff members, which are temporary basis. And once when it is temporary appointment, then funding agency don't give any funding for such students. So they have to get from somewhere something and do sit and wait, and research doesn't go into a good grade research cannot be done also. Basic research also cannot be done. So these are different problems which I was facing there. Maybe some more also, which if you ask questions, I may give that. So thanks a lot for.
Thank you, Dr. Gangal, for
Getting
this excellent overview. Yeah, friends, we have a good gathering of academia as well as industry in today's discussion. So we will go open the platform for question and answers, and also comments from industry as well as academia experts. So I could see Dr. Anil Jain from Ambala, Dr. S.P. Bhatnagar from Ahmedabad. We can see Dr. Siddhartha Dasgupta from Kolkata. So there are many experts present. Vijay Ghati from Philips India, ex-Philips. So we would like to have this session recorded, and these inputs will be used for the brainstorming as well as finding the action plan for converting education or university research into a product or services. So let's start. Plus, identify yourself and please ask the question.
Namaskar to all the participants. This is Ganesh Rajugopal representing EduFuture. It was a very insightful kind of a presentation from the professor. Absolutely, thank you, ma'am, for honestly coming out with certain points, which really is the addressing factor that we need to take up as on today. Like, for example, I deal with a lot of institutions in terms of, I was part of NAC to begin with. So during my processes, visiting many institutions as a peer visit, as a peer team member, what I found is from an academic perspective, one, let us understand all the universities across pan-India or state legislative run institutions. So we don't have a centralized kind of an institution, which comes under the central university status, which we have the president as who is called as a visiting member.
Hello.
After having said this, why I speak about this is, if we have a uniform kind of an education process.
नमस्कार काका, मी ना आता ह्याच्या युनिव्हर्सिटी आणि ह्याच्या झूम मीटिंग वरती आहे, टेक फोरमच्या. हो 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 आहे, माझं लक्ष आहे त्याच्यामध्ये, आणि ते झालं की मला ताबडतोब फोडलं.
Anil, please switch off your mic. Continue, Ganesh.
Can I continue, sir?
Yeah, please. Sorry.
Yeah, thank you. So what I would really look into, step number 1 in my experiences of accrediting many institutions, science as a central as well as medical universities. First and the foremost thing is, as the professor did mention, most of the faculty conduct and complete the research more from from UGC perspective or from the university perspective or the statutory body perspective, more in terms of getting career promotions. One. In my experience, again, most of the, I stand to get corrected, majority of the faculty's research papers are not even available in the library of any particular institutions. So when a student, he or she goes for citations or indexing, it is very unfortunate. Majority of the students don't know the faculties themselves have published papers. This is another part which we found out. So what we have done is, I just have what also I've done is, we have recommended the HOIs, that is the head of the institutions in the particular university, so that to appoint right support system in terms of first library. So in the library, the chief librarian, we have recommended conducting of regular online workshops how to for the students and the faculties of to do an online indexing and online citation. We have done this many times. We have done this. When we come from the industry perspective, industries, because what happens is most of the syllabus, again the professor will agree with me, most of the majority of the syllabus that we've written, it is still not meeting what the industry requirements are. Unfortunately, it is not. Like, for example, I will just take pharmacy to be very short to the point. When I take pharmacy, a student who's completed a pharmacy program, he or she can also get into various activities in a pharmacy. So, what is generally perceived, a pharmacy student will have to open only a pharmacy shop. I talk about why can't a pharmacy institution teach about manufacturing? In manufacturing, supply chain. In supply chain, we talk about so many things, but it is never there in the syllabi. We talk about manufacturing and engineering. I don't know how many people know what are warehouses, how to raise an intent, what is the interdepartmental intent. Nobody knows the manufacturing process. I mean, it's sorry. So the entire process from the education perspective, we need to bring in a better syllabi into the system. Now it is question, who is going to build the cat? This is a challenge. So hence, of course, what we have done is we have created a wonderful program in academia, industry program addressing 5.0. I would really love, my organization would really love, which Mr. Vilas has been very kind, Mr. Vilas Apte has been very kind with his blessings, with his encouragement, we're working on it. Another thing I would like to address is today, now when we talk about research per se from industry perspective, we are talking about where UGC has informed POP, professor of practice from industry can be appointed to talk about industrial activities in education. We are encouraging that. Second is definitely yes. Ma'am knows about it, the professor knows about it. We were talking about NEP. If NEP has to be implemented, we have a lot of political challenges, each of them, which I will not get into it. Then again, we're talking about a credit-based system, ABC. We're talking about academic bank of credits. So all this can, how exactly a university can utilize these factors to improve research and students' output. This is my take, please.
We have noted your point and we will have a presentation on this topic. Very interesting. Let us give chance to others. I request everyone to make it brief and short.
So my talk is over, sir. My talk is over. Thank you.
Next question or comment.
Yeah, this is Vijay Ghate. Vilas, can I speak a little bit?
Yes, please.
Okay. I want to point out two things here. One is we very casually use the word R&D, research and development. Okay. I think these are different things. What Madam mentioned as a basic research is something which is more, which is a research. What industry needs is a development. Now, what is the difference? Research aims at understanding natural phenomena, and possibly they may relate to universe, or they may relate to materials, or they may relate to some specific technologies. While development, they want to find out a solution for real human problems. Normally, funding for research is say public funded. That means from tax money, government, or whatever. While development is activity is commercially funded. It is difficult to come together in these two completely different environments. But still, in other countries, there have been a lot of products which have really stemmed from research in the university. So for that, the research has to be a little bit ahead of what would be expected by industry. And industries must be able to take the research results and convert them into real technological solutions for people. I think somewhere there are difficulties in industry, there are difficulties in university, and so on. But I think there is a need that we have to resolve and find a common ground. I don't know how this can be done, unfortunately, because I've been facing these problems for many years while I was in industry. Then I participated actively in various university forums, in syllabus committee, and so on. But I think we have still not found a solution for this. That's what I wanted to mention. But still, Madam, you mentioned several technology works that you did. Now, there's a problem when those students go away, that technology remains at some stage and so on. What sort of documentation and retention of knowledge practice that you follow in the universities? I would love to hear that. Suppose somebody wants to, in industry, wants to take over that scale that you developed and now develop further. How can that be done? Is it available? And when you say technology transfer, what is it that you would transfer normally? I think if you can say, if you throw some light on this, it will be useful.
Actually, when it comes to, I mean, if it is an industrial project, we do write a technical, we make a technical documentation.
Right.
But else, when it is a research type of thing, it goes into a research paper and finally a thesis. Thesis also is quite a detailed information is available.
Okay.
And that can be utilized for, I mean, it is finally a published thing once it is a thesis.
Yeah.
Then that can be utilized. But if one wants to get a more detailed information on what has happened, then one has to contact the faculty or the research student. Faculty, if research student goes away, faculty can call him and get it, get the information taken from.
Okay. Okay. Difficult, right?
Yeah.
It's difficult. I mean, it's difficult on both sides. On industry sides also, it is difficult. I know. But we have to solve this. Otherwise, make in India and so on has no meaning. You know, make in India is meaningless unless it is also developed in India and knowledge is available in India. That's the worrisome situation.
I mean, there is something is missing, and I'm also not able to get what.
I know. No, I think this is. Yeah. It is not a forum for
Especially in the
criticizing.
science universities.
Yeah.
Engineering departments may be different because like IITs and all those things.
Just one related question. University department, which is more electronic sciences, and say ENTC of COAP Tech University, where they have more practical knowledge approach probably. So have you ever thought about a joint project?
Initially for semiconductor science and technology, it was instituted by the UGC and
Yes.
Department of Electronics.
Yes.
And we were to do a lot of research work in semiconductor science and technology. That time it was not commercially products were. I mean, we
Yes.
then worked on microelectromechanical devices and semiconductor devices. But what happened was, I mean, we could not make good devices because of the facilities available.
Yeah.
So once I was talking to Dr. V.G. Bhide, who was Dr. V.G. Bhide was the Vice Chancellor at that time.
Yes.
And he was in the physics department and I had known him very well. So he was talking to us on the research what we were doing. So we said that we do not get semiconductor devices, whatever we fabricate is not good. So he said that any device which is not working good can be a sensor. Can be a sensor.
Yeah.
Because if it is a device is temperature sensitive because of some some wrong thing what you have done for developing the devices, then it's a good as a temperature sensor because its characteristics changes, and then you can modify the materials to get a bad material so that you get a good sensor.
That's a good idea.
That is what we did afterwards for working on the various sensors what we had, because since we did not have a good equipment and all those things, and access was not available to semiconductor science and semiconductor complex limited for training the students or for getting something which is designed by us. So that was a very sad thing.
Has anybody
We
considered?
have complete facility in our university also. But what happened is the funding agency, they said, I had also proposed a MEMS technology equipment in the department, in the university. And what happened was everything was correct. The Siri Pilani scientist also had uh, said that I need 2.5 crores for such and such facility. My thing was 2.72 72 crores for the facilities available. But it was not given to me because the funding agency said that they have an apprehension on the university working and all that thing. And because after 5 years, they will fund it for 5 years.
Yeah.
What will be the status of that equipment after 5 years? Because university doesn't give us any funding for maintenance and repair, any funding for the appointing operators and all that thing on those equipment. So it cannot be done by a single person. It cannot be done by research students calling them from the whatever they are working. So it has to be a permanent staff, and that was not available, and therefore I accepted afterwards that, and then I never then asked for a big money. Because it's not possible to get anything from university, such type of.
I'm Dasgupta. My comment after hearing this whole narrative is that perhaps a research undertaken in a university, perhaps it lacks a project approach. See, a research is a project, and today there are so many interfaces during the tenure of the research. So if a research takes about 3 to 4 years, you have so many things to be considered, so many people to be contacted, so many issues to be resolved. So basically, I believe that unless a project approach is taken at the beginning, at the very beginning, in a proper way, where you can conceive, you can think about all the future problems that may arise, and then take preventive action, at least in your thought. What will be the likely problems? What are the likely solutions? Where you have to go? What references you need? The entire thing should be mapped out as a project. And the modern day project approach is very, very precise. You can be as precise as you want to be. And the research should be cast in the mold of a project. Then I believe chances of success will be far, far higher. That is my comment.
Yeah, thank you.
Let's give chance to others. I think Dr. Rajesh want to say something.
Yeah. This is S.P. Bhatnagar. Can I say?
Yes, sir. Please continue.
Yeah, please continue because you have worked in academia as well as industry. Please go ahead.
Yeah. Thank you, madam, for expressing so well. Actually, I am also from academics, and then now I'm retired, but we had a lot of industrial collaborations. Some of them really succeeded well. Whatever problems you are facing from in the university side, they are universal in the country. I have visited many universities and found the same things happening. Reason is very simple. The whole environment is not suited or not designed for research. Most of the people only think of university as a education thing which conducts examination. And hardly anybody bothers about the R&D part, both R as well as D part, both of them. So we have faced the same situation, and somehow we could do a little bit here and there. With extreme lack of manpower. I was in a very small university called Bhavnagar University, and you will be surprised, I was running single-handedly the department. Only one post was sanctioned. Out of 4, 1 was filled, and not even temporary posts were given. So it was how we managed, I don't know. Somehow we could do it. Very, very difficult because you have to conduct the regular classes, plus the PhD students, plus the academics and other administrative duties, because people are less, so more hours to be spent on those. So anyway, all those things are common all across the country.
Yeah.
I think I had very high regards for the Pune University because I was involved as a student in 1980s when Professor M.R. Bhide was there. And I worked with Professor Boraskar also. We had our common papers as a student. I was a student. I had published. And a lot of faculty in Pune University, I personally knew Professor Gashe, Professor Boraskar, Mrs. Boraskar. So I had a lot of Professor David also. I personally had contact. So when I see things happening there similar to what happens in smaller universities, I realize that things have changed a lot and not in the direction. One more comment I want to do is why we should bother about the university research going into industry. Because we always look at the American system and see that or other countries. But we only see that part. Why don't we see what kind of facilities they are providing? I have contacts, I have got professors visiting our department, and they were given 40, 50 research assistants to conduct the classes, to conduct the labs and things like that. Here we don't get even one person to assist us. So we can't expect the same thing, what is happening in US, unless we provide the same kind of environment here also. So ma'am, that is the thing, and I think you have done it very well. Thank you very much for expressing on behalf of academics. And also, Vilasji, and industry should be active in forming the syllabus or at least expressing what they need for next 5 years or 10 years so that universities can provide that kind of manpower. Engineering is completely different from the basic sciences. You should not expect basic sciences to provide ready-made solutions to industry always. There are many places we have done it, and some of our products are being sold, are manufactured and sold also by industry, and some of 1 or 2 products are universal kind of things. So that is not a big thing. I mean, that's not something which is there. But should not compare engineering sciences like IITs doing research and providing the support for industry, and the universities which are more on the basic sciences. And so that these are some of the few comments which I thought I'll share. Thank you very much, ma'am, for.
Yeah, thank you, Bhatnagar, for this wonderful input. Definitely, they will go in our action plan. But I can give a very shortly small example. 1995, we worked with some of the students from Pune University and developed a machine called plasma assisted reactive etching. This machine was used.
Rabdaji, we lost your voice.
That machine,
Rabdaji, you are not audible. Vilaji, you are not audible.
The next speaker. Please check up the next speaker, yaar.
Next speaker. Please take the next speaker. Next comment, please.
Make some observations.
Next speaker, please.
Next
This
question.
is Anil. I wish to contribute.
Yeah,
Yeah,
please, Dr. Anil Jet from Ambala, please go ahead.
Yes. At the outset, I must offer my compliments to Dr. Gangal for a very genuine effort in making industrially viable products. My special reference shall be to a product which is a 10-meter scale for CNC machine made on the collaborative efforts of Electronica. This is, I think, a beautiful example Madam has quoted, that they successfully developed a 10-meter scale for a CNC machine. And at the end of the day, when that product was completed, as I understand, there were cheaper scales available from China, and resultantly the product could not see the light of the day. At this moment of time, I would like to make a mention that the Chinese products, we have an experience in Ambala Kent that the microscopes which we were manufacturing in Ambala industry abundant producing microscopes, they starting importing ready-made studio zoom microscopes, micro hardness testers, and other equipment from China, which were much more cheaper, much more aesthetically strong. But at the end of the day, whenever there was an after-sale services requirement, whenever there was a spare part requirement, those were not at all available. It is at this moment of time I would like to mention that once the 10-meter scale for CNC machine was developed, probably in the first instance, the industry could be informed that if they would be using this 10-meter scale as against a Chinese scale, the maintainability of the scale designed by Pune University under the leadership of Dr. Gangal would be much more viable than the Chinese products which are available in the market.
Thank you, Dr. Anil Jain, for this input, wonderful input from Ambala. Please go ahead.
That these days, the industrial associations are providing a very good group and a very good bridging in terms of collaborative arrangements between the university research and the requirements of the industry. And the madam described that that is a true situation, that the university authorities take abnormally long time to sanction the fundings and lot of red tape and lot of bureaucratic hassle. I should mention very specifically that IMA, the Indian Electrical and Electronics Manufacturing Association, they have concurrently established in Vadodara an organization called ERDA, Electronic Research and Development Agency. And they are working very closely in collaboration with IMA, meaning IMA is the industry which represents 1,000 industries plus in electrical and electronics area. And ERDA is the development and research agency which is undertaking the research projects either for the upgradation or for the maintenance or for initiation of new products. I would like to submit that if Pune University, which is a very rich repository of intellectual capital in the country, probably industrial associations can play a very good role in providing you very quick support in terms of finances, provided the product which is coming out, they are already ready to receive it and they are aware of it right at the inception of the stage, as one Dr. Bhatnagar mentioned in one of his presentations, that before we start the production, before we start the research, let us take one or two industries or the industry association in confidence to go ahead. I think funding of 10 lakh, 20 lakh, 50 lakh these days is not a problem in the industry. They don't have the time to develop and design the products, and the university can fill up that gap.